Okay, we will now move on to note 7.1. This is the title of this section is sine and cosine ratios of obtuse angles. So you can see from the first side of the notes here, we have all the definitions should already be quite familiar with all these definitions. So I'm not going to go through here, but some highlights I want to show to you here when we have the first portion here, the sine of angle. uh, we already know that is equals to opposite over hypotenuse. So to summarize here, that the sine theta here is O over H, and this is taking its cue from Tuakaso, so this is SOH, sine equals to opposite, or sine theta equals to opposite over hypotenuse. And for the second trigo ratio, which is cosine, we have cosine equals to adjacent over hypotenuse. So we will have cosine theta equals to A over H. So again, this is from the Tuakaso on the car part. And finally, for tangent of angle, we have tangent theta equals to opposite over adjacent. So tangent theta is equals to O over A. So this is the Tua part TOA. So we have Tua, we have Ka, we have So here. So that is the Tuakaso that we have learned before. Okay, so let's move on to our recall example here. So this is an example that we have to revise before we move on to 7.1, the actual section. So if you look at the diagram, there is actually there are two triangles. We have triangle ABC and triangle ACD. So the first question is to find the side X. So if you want to find the side X, we look at X, we can draw a small triangle here just to highlight the triangle that we want to focus on. And this is A, B, and C. You have same value 16. You have X that you need to find, and you have 28 degrees. So we are going to focus our question for sine X to find sine X with just this triangle. You notice that from the 28 degrees that we have here, 16 will be the opposite and X will be the adjacent. So O and A, we can use tangent. Okay, so we are taking tangent equals to O over A. So tangent of 28 degrees is equals to 16 over X. And we can get X from exchanging place 28 degrees with X, and this will give us an answer of 30.0916 to 3SF will be 30.1 cm. Okay, so that is the first part of the answer. For the second part, to get Y, we can still focus on the same triangle. So I'm going to draw the triangle again. So it will look like this. We have 28 degrees. We have a right angle triangle here. We have Y, we have 16. So this is a triangle ABC, and then here we have 28 degrees. So we can find Y from 28 degrees. We have 16 as opposite and Y as the hypotenuse. So we are going to use O and H. So sine of 28 degrees will be opposite, that is 16, and we have hypotenuse, and that will be y. So here, if we focus on this triangle on its own, we can get the value of y from 16 over sine 28 degrees. So that will give an answer of 34.081, and final answer will be 34.1 cm. Finally, when you want to find the last value for z, okay, if we already have y value, which is 34.081, here we have 42 given, we can find the angle z by using Pythagoras theorem. So notice that this is a right angle triangle, so it is possible to use Pythagoras theorem for this. So let's highlight the triangle, or draw again the triangle. So the triangle will be drawn. In this case, the triangle drawn is ACD. So E, C, and D, and CD will be Z. AD is given 42, and the AC Y, which is the value of Y here, is given as 34.081. So this was from the previous working. So by Pythagoras theorem, we have z squared plus 34.081 square equals to 42 square. So we will have z square equals to 42 square minus 34.081 square, and we can get z by applying square root on the right hand side, and we will get an answer of 24.546, and final answer will be equals to 24.5 cm. So this is to three significant figures, and we have answered the first part of the question. So the second part of the question is to find the angle theta. So we can use the same triangle. We can use this triangle here. The triangle that I've highlighted here. So this is the triangle ACD, and we can apply using the information that we have got in. So we're going to draw the ACD again in the space provided for B, so that is clear that we can apply a certain trigonometric ratio for this question. So let's draw it again. So on this portion here, we have CD, which was obtained a value of 24.546, and here we have 42. So from the theta point of view, so this is the theta, we need to find theta. So 24.546 opposite, 42 will be the hypotenuse. So this is using so, because we have opposite and hypotenuse. So sine of theta is equals to 24.546 over 42, so opposite over hypotenuse, and theta will be sine inverse of the right hand side. So that's 24.546 over 42. Press the calculator, you get 35.762 degrees. So correct to one decimal place would be 35.8 degrees.